this unit, we're going to continue our look at number sense. In this lesson, we're going to be determining square roots and cube roots with prime factorization. Okay, hi everybody. So in this lesson, we're going to be determining square roots and cube roots using prime factorization. Okay, so our focus here, okay, this is what we're trying to do here to accomplish at the end of this lesson, is to identify perfect squares and perfect cubes with prime factorization and calculators, and then to determine those roots. Okay, so first of all, we're going to spend a little bit of time just, again, reviewing what it is to be a perfect square, what it is to be a perfect cube. Look at the calculator. Then we're going to show you how to use the tool of prime factorization, which we've looked at in a previous lesson, to find these values. Okay, so just some things to review here. Any whole number that can be represented as the area of a square with a whole number side length, okay, and that's important here, is going to be a perfect square. So for example, let's say that you've got a square that's got an area of 25. Okay, I know that we're getting that, particularly if this is a square here, that this side and this side would be the same thing. So this is x squared is equal to 25. Whoops. I know that x must equal 5. The side length of this thing must be 5. Okay? Now, and we've talked about that in a previous lesson here. Now, the square root of n is going to be written as root n. So this is, in essence here, think about this. This is the area, and this is the side length. So for example, in here, this was 25. So if the area is equal to 25, my side length, let's say x is going to be the square root of 25, and that works like this. I know that I'm getting the area by multiplying 5 times 5, and I want to make sure that this makes sense so that later on when we do this, it's clear to you. 5 times 5 is giving me the 25 here. This means that and I'm getting that area by going length times width. So if those are the same, then I know that I've got a square here and my side length is going to be 5. So because that shows up as a pair there, my answer is just that single 5. The side length of the square is 5. Now, on the other hand, if I've got the side length of a square is root n, then the square of that is going to be n. Okay, in other words, if this is, let's say, root 3, and this is going to be root 3, I know that my area is going to be, root 3 multiplied by root 3, and that's just going to give me 3. Now, that might take a little bit to think about here, okay, but watch this. If I've got, for example, the square root of 9 multiplied by the square root of 9, now just think about that. The square root of 9 is 3, square root of 9 is 3, 3 times 3 is 9. So root 9 multiplied by root 9 is eventually 9. Okay, if I did root 16 times root 16, well, that's going to be 4 times 4. Well, that just equals 16. So notice here, root n multiplied by root n, or root n squared, must equal n. That one there is maybe a little less obvious. Now, but this same pattern of thinking can work with cubes. Okay, so now we're not talking about the area of a square. We are talking about the volume of a cube. Okay, or maybe I should have used S there for this side length. Well, I'll just use S. Just to be consistent with this, we'll use the S here. So in this case here, if I know that the volume is going to be S times S times S, or S cubed, and I know that in this case that's going to be 27, what I'm asking myself here is what number multiplied by itself as a factor 3 times gets me 27? And the answer in this case is that the side length has to be 3. And so to get the side length, I would do the cube root of 27. And I know that I can write 27 as 3 times 3 times 3, and that's the length times width times height. They're all the same because I've got the same number written out 3 times, so I know that the side length, okay, and I'm not going to, I wouldn't say 3 and 3 and 3. I'm just going to say that the side length of the cube is 3. I'm just going to give the one number because it's going to be the same for all 3 side lengths. So we write the cube root of n as this, with that little root index here. We're going to call that our root index, the number that you throw there. And it's saying how many times am I using this particular number as a factor. So if I have a 3 there, I'm looking for 3 factors there. And at the same time, if I take that and cube it, if I take the cube root of n and cube that number, my answer will be n, just like it was when I squared a square root. Okay, anyway, we're going to take a moment now and we're just going to take a quick look at cube roots. We're going to make sure that you kind of understand how we're doing it and how to use the calculator to get it. Okay, so our question is determine the exact cube root, and if this is not possible, round to the nearest tenth. So here we go. So I've got the cube root of 27. So again, how I interpret that is to be the volume of some cube is 27. So what I want to do is I want to break up 27 as far as I can. And so you're going to see, we're going to talk a lot more about this in just a bit here, but 27 is the same as 3 times 9, which is the same as 3 times, well, 9 is 3 times 3. And so here, because I've got the same number as a factor 3 times, I know that that means that this must represent the length, the width, and the height. And that's how I'm getting the area, the volume there, I should say. All 3 of those are the same, so that means the side length of my cube is just going to be 3. That's it. So the cube root of 27 is 3. Now, maybe I look at this and the cube root of 1 over 216, and I'm not entirely sure how to handle that. Well, that's okay. That's okay. This is why we want to take a look at this. So one way to do this is to play with numbers that you're kind of comfortable with. If you're not comfortable with that, there is another way to do that. Let's pull up the calculator. Now, you might wonder, with a calculator like this, well, where is that cube root button? And yeah, that's a good question here. Actually, I'm going to just focus this. So first of all, I'm going to press the math button. And the math button opens up this menu here. This is cubing, and right here, this is my cube root. So I'm going to press enter on the cube root, and then I'll enter 1 divided by 216. Okay, now, when I press enter, I get this as my decimal. So this is approximately 0.2. But it turns out, with this particular calculator, I can do actually a little bit better. On a graphing calculator like this, a Texas Instruments like this, if I press math, the very first option that I get is convert to fraction. So I would use this to convert that answer to a fraction, and I get 1/6. So this is actually equal to 1/6 perfectly. Now let's take a look at my little pink calculator. Okay, so where would the cube root be here? Well, if you look at the options here, I am not seeing a cube root. But what I do see is the xth root. Okay, so now what I would do with this one here is if I want a cube root, I would first of all press 3, then I would press second and this xth root one, and then now I have to put parentheses here, because what I'm going to put after this is a little bit of an expression, and if I don't put parentheses around it, the calculator won't know exactly what it is I'm taking the cube root of. So 1 divided by 216. Okay, now this calculator doesn't have the ability to just convert to a fraction. Okay, so I'm looking for this decimal to pop up. If this decimal pops up, I know that I've done this correctly here. And when I press equals, there it is. I get 0.166 repeating, okay? And so there it is. So that calculator is giving me the cube root, but that's how you do it. You have to tell it what kind of a root you're doing, and then you press second, and then my little caret symbol here to get the xth root. Now for this one right here, the cube root of -1, okay, well, if I took the square root, now watch this, if I take the square root of -1 on my calculator, I get this error, this non-real answer, okay, which means that there's something kind of different going on here. But now I'm going to walk through the process of taking a cube root. So I will go math, number 4, down to my cube root, and I'll enter -1 in here, and I get -1. So it is possible for me to take the cube root of a negative number, and it turns out my answer will be negative. And that actually makes a lot of sense, because I can rewrite -1 as -1 times -1 times -1. I can use it 3 times there. Now, if I'm talking about the volume of a shape, maybe it doesn't make much sense to talk about a negative side length. But the point is I can do that. Now here, I've got a negative outside and inside. So there's going to be a negative, and then I'm going to deal with the cube root of negative 8. Now, I know that 8, okay, this is like what I was doing over here. I know that 8 is 2 times 2 times 2. It's 2 times 4, which is 2 times 2. So that negative there, though, is there because I could do that negative 3 times. Just like with this previous one, where the cube root of a negative is a negative, it doesn't really matter what the other number is. So the cube root of negative 8 is going to be, well, negative 2. There's 3 negatives 2 there, negative 2's there. So that represents the length, width, height. Well, I don't care about calling it length, width, height anymore. I'm just going to call it the side length, negative 2. And then finally, I've got this negative out front. So the negative of negative 2 is positive 2. And so that would be the answer to this particular expression here. Okay, so now what we're going to do is we're going to talk about how to use the prime factorization of our number to get its square root. Okay, so we've got square root of 144. We're going to use prime factorization. So 144 is 2 times 72. There's my prime. 72 is 8 times 9. Okay, neither one of those is prime. But 8 is 2 times 4. There's my prime. And 4 is 2 times 2. There's my 2 primes. Okay. 9 is going to be 3 times 3, and those are my 2 primes here. So what I've got here is 144 is going to be 2 times 2 times 2 times 3. Sorry, 2 times 2 times 2 times 2 times 3 times 3. So when we list off those factors here, what we're looking for is we're looking to break these into 2 equal groups. Because remember, that symbol is trying to take us from an area to a side length of a square where the 2 sides are the same. The length and the width are actually the same value here. So what I'm trying to do is break these up into identical pairs of factors. So this would be my length, this would be my width, meaning that the side length of my square would be 2 times 2 times 3, or 12. So that's the point. That symbol right there basically takes pairs of factors and spits out single factors for each one. So, for example, I might have written it like this. The square root, another way of looking at this is square root of 144 could be written as the square root of 2 times 2 times 2 times 2 times 3 times 3. There's a pair of factors there, a pair of factors there, and a pair of factors there. So every time I can pair up a factor, I put a single factor out. This is length and width, side. Length and width, side. Length and width, side. So 2 times 2 times 2 times 3 is going to be 12. Anyway, with that in mind, let's take a look at some examples, and maybe that'll help clarify it. Okay, so here we go. Determine the square root of 1,296 using prime factorization. Okay, so here, first of all, you've got 1,296. First of all, we're going to divide that by 2. Okay, and that's going to be 2 times 648. Now I'm just going to keep pulling out 2's here because 2 is prime. So 648 divided by 2, 324. 2 is prime. I'm going to divide that by 2. 162. 2 is prime. I'm going to divide 162 by 2. Now, 81 is not divisible by 2, so I got to stop doing that. So now I think, what's the next prime? Well, the next prime is 3. And 81 becomes 3 times 27. 27 is 3 times 9. And 9 is 3 times 3. So now I've broken it down. I've got 1,296 is equal to 1, 2, 3, 4. So 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. Okay, I've got 4 2's and 4 3's. So I can split up the 2's into 2 groups to 2 pairs, split up the 3's into 2 pairs. So 1,296 is going to be 2 times 2 times 3 times 3 times 2 times 2 times 3 times 3. So in other words, the square root of 1,296 is going to be, now remember, this is my length, this is my width, but it's a square, so they're the same thing. So the side length would just be this right here, and 2 times 2 times 3 times 3 is going to be 36. So the square root of 1,296 is 36. Now, we can double check that. If I pull up my calculator here, if I take 36 and square it, yeah, there we go. 1,296. Good, I got it. Let's take a look at another one. We're going to determine the square root of 1,764 using prime factorization. Well, I'm going to approach this the same way I approached the last one. I'm going to divide by 2. And I get 882. I'm going to divide that by 2. And I get 441. Now, yikes, that quickly got rid of my prime numbers, because 441 is no longer divisible by 2. But I can divide by 3, and I get 147. Okay, and that is divisible by 3, or at least I'm going to try. And I get 49, and then 49 is going to be 7 times 7. So 1,764 is equal to 2 times 2 times 3 times 3 times 7 times 7. So this is not that hard to group these into two distinct groups. I've got 2 times 3 times 7 times 2 times 3, times 7. So the square root of 1,764 is going to be just one of those. This is length times width, but they're exactly the same. So one side length is going to be 2 times 3 times 7, or 42. Okay. Now, I know I'm being repetitive there, but I'm hoping that with the repetition kind of helps you remember how this works. Let's take a look at another one. A square has an area of 324 square inches. What's its side length? So my side length, remember, and this is exactly what this notation is all about here. We're going backwards here. So 324, if I did, just off to the side of my calculator, 324 divided by 2. Okay, actually, you know what? I'm going to do this over here. 324, if I divide that by 2, I'm going to get 162. There's my prime. If I divide that by 2, I get 81. And you know what? I just spent a couple moments working with 81. And then 9 is 3 times 3. So I know that 324 is going to be 2 times 2 times 3 times 3 times 3 times 3. And I can actually break this up into two groups of 2 times 3 times 3, 2 times 3 times 3. There's my length. There's my width. Because this is a square, they're the same, so my side length is just going to be 2 times 3 times 3, or 18. Now, if that's true, if I square 18, I should get 324, and I do. So anyway, my side length here is going to be 18 inches. Now, to define the cube root of a number, using the same method, what we got to do is we just got to change how we kind of conclude our work here. So for example, we're going to find the cube root of 216. Now remember, finding the cube root is like being given the volume of a cube and asking you what the side length is. Now remember, the side length is going to be the same for your length, your width, and your height. Okay? So then what I'm looking for here is I'm looking for a way that I can take 216, break it into its prime factors, and look for some factor, some group of factors that gets repeated 3 times, once for the length, width, and height. Or I should have gone length, width, and height there. So to break 216 apart, okay, I'm going to divide by 3, then divide by 3, divide by 3, divide by 2, divide by 2. Then there we go. So it's 2 times 2 times 2 times 3 times 2 times 3. So I can make that 2 times 3 times 2 times 3 times 2 times 3, which means 216 is 6 times 6 times 6. So in other words, the side length of that cube is going to be 6. That's my cube root. So I'm looking for a triplet. okay, when we're dealing with cube roots, I'm looking for a triplet of factors that I can use to represent the side length of the cube. So let's take a look at some examples and see how that works. So this question says, determine the cube root, my mistake, cube root of 1,728 using prime factorization. Okay, so here we go. 1,728. So I've just got my calculator off to the side here. So first of all, I'm going to divide that by 2. That's multiplied by 864. So there's my prime. Then 864 divided by 2 is 432. 432 divided by 2 is going to be 216. 216 divided by 2, oops, is going to be 108. 108 divided by 2 will be 54. 54 divided, now I'm just going on and on forever here, divided by 2, 27. Now finally, 27 is not divisible by 2, but it is divisible by 3. And then 9 is 3 times 3. So I'm looking for the cube root of 1,728. Well, that is going to be the cube root of 2 times 2 times 2 times 2. Whoops, I got to count the 2's here. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 times 3 3's. So I can rearrange this to create 2 times 2 times 3, 2 times 2 times 3, 2 times 2 times 3. Okay, I've got a triplet of this particular factor here. So this represents my length, my width, my height. So in a cube, they're all going to be the same. So my answer here is going to be 2 times 2 times 3, or 12. That's going to be the cube root of 1,728. Let's keep going. So the next question is, determine the cube root of 2,744. And we're going to basically approach this the same way. So just off to the side here, I've got 2,744. In fact, the only way I can anticipate this getting more difficult for you is just if the prime numbers that they use are a little bit larger. But even that's not going to slow you down too much. So the first number that we're going to do is we're going to divide by 2, and that gets us 372, which I'm going to divide by, which I'm going to divide by 2, and that gets me 686, which I will divide by 2 to get 343. Now, wow, so not 3 times 3. I did the same thing with that last step there. It's kind of weird. Now, 343 is not divisible by 2. Turns out it's not divisible by 3 either. It's not divisible by 4, because if 2 was, then I would question whether 4 was, but it's not. It's not divisible by 5. Turns out it's divisible by 7. I got to go all the way up to 7, but 7 is a prime. And then 49 is going to be 7 times 7. So now I've got my prime factors here. So I want to figure out the cube root of 2,744. That will be the cube root of 2 times 2 times 2 times 7 times 7 times 7. And I can create a triplet of 2 times 7. There's my length, my width, my height. 2 times 7 is the cube root, and that's 14. And then finally, one more example. A cube has a volume of 4,913 cubic inches. What is the surface area? Actually, that makes me wonder if I did that other question wrong. Just hold on one second. I want to make sure that... No, that's fine here. What is the surface area? Okay, this is taking us one step further. We'll talk about that in just a moment here. So first of all, though, we got to figure out what the cube root is going to be. Now, 4,913 is not divisible by 2. 4,913 is it divisible by 3? Nope. It's not divisible by 5. Is it divisible by 7? Nope. Is it divisible by 11? Because that's going to be my next prime number here. Nope. 4,913. And actually, I should probably be doing this in front of you here. So let's walk through this again here. So I'm thinking about my primes. So it's not divisible by 2. It's not divisible by 3. Is it divisible by 5? Well, it's not divisible by 5. I can tell that because that would be end in a 5 or a 0. It's not divisible by 7. It's not divisible by 11. So the next prime is 13. It's not divisible by 13. So basically we just keep going up our primes here. 17. And there it is. Okay? This is 17 times 289. So that's my first prime. Now here's the thing. If 4,913 was not divisible by any number up to 17, then 289 won't be either. Because if there was another factor in there, a smaller factor, we would have found it. So the best that I could do here is say, well, okay, is 289, is that divisible by 17? And there it is. So that's 17 times 17. So here we go. So the cube root of 4,913 is going to be the cube root of 17 times 17 times 17. And so that makes the answer 17 inches. That is not actually the answer to this question, but that's where I need it to be. So this question is asking for the surface area. So here's my cube. I know that the length here is 17, the width here is 17, and then the height here is 17. Now, that means each one of these squares, and I'm looking for the surface area now, each one of these squares is 17 by 17. So the area of a square is going to be 17 times 17, which we just saw a moment ago is 289. So each one of these faces is 289 inches squared. Now the thing is, how many of those faces are there on a cube? Well, there's 1, 2, 3, 4, 5, and at the back there's 6. So there's 6 of them. So the surface area of the cube is going to be 6 times 289, and it turns out that amounts to 1,734 inches squared.